Okay, so here's your notes for the day. These are going to be equations where you get some information, and then from that information you got to find the equation from that information. So this is what you do first. You go like this, and so even though I've done this forever, I still draw everything out. Now I like making the foci as little x's. So X marks the spot for the foci. All right, and then then I read that the minor axis has a length. Oh, did I get your attention? Length of 4. But let's go back to so the foci are this way. So who has the bigger number underneath the x squared or the y squared? Y squared. Okay, so these are Mickey Mouse examples to start off with. That you did, I'm pretty sure, last year. It'll ratchet up a little bit pretty quick. And then I have a worksheet for you to do that. We almost got done second, or I think I blabbered too long, so it didn't give them enough time. But you guys, I'm going to hold to a higher task of getting that worksheet done before you leave, and I'm going to grade it. Maybe. We'll see how it goes. All right, why did I put x squared plus y squared, by the way, instead of like numbers with x and y squared, x squared and y squared? Because the center is where, based off the foci information. 0, 0. So that's why I know this is the case. So all I really have to do is fill in the numbers underneath x squared and y squared. That's why it's a Mickey Mouse question. By the way, the minor axis length is 4. Whoops. So how far do I go right and left from the center? 2 and 2. Okay, and I made that look a little bit longer, but I should have, this scale's wrong. You know what I mean? Like the y numbers look shorter than the x numbers there. I want to make this look elliptical, so I do want about the same scale. If I've done that. So what number goes underneath the x squared then? What number goes underneath the x squared? It is 4, not because the minor axis length is 4, so it's 4. It's because 2 squared is 4, because the x-axis radius is 2, so that was a coincidence. So how do we get the y number? Come on, you know it. I'm not even going to ask you. Got some tougher things I'm going to ask you later. A chance to win a prize. Someone won 1 second hour. Okay, whoops. Do I have C? Yes or no? What is C? 3 squared. It's 3, so it's 9. Do I have A? Yes or no? Nope. Do I have B? Yes. Okay, so what do I put there? 16, 2 squared, 4 squared. What do I put? 2 squared, which is 4. All right, a squared equals 13. Do I even root this? Yes or no? Do I really need it rooted if all I have to do is fill in the number that's needed? The answer was no. You just put 13 underneath there, and then you move on. To sketch with a graph, you'd have to subtract x squared over 4 from both sides, multiply both sides by 13, and then root both sides. When you root both sides, what happens? Ding-a-ling. Plus or minus. So to graph this ellipse, you'd have to do y1 equals plus, y2 equals minus, and then take a look at the connection of those two graphs. Not covering that any further. Uh-oh, we have an issue. All right, let's move on. Let's turn. If I didn't have the video on, there would have been, yeah. All right, here we go. Okay, so even mathematics boy over here, that's me, the shirt and everything, still draws this out just to make sure I know what I'm dealing with. 1, 2, 3, 4, 5, 6, 7, 8. Doesn't say make a sketch, but those are the endpoints of the major axis, which would also be called what? Which I don't think it's a great word for this, but what? So if it said the vertices are, your job as a student is to know that vocab word. Okay, so where's the center? In the middle. But where is the center? Where's the center? 3, negative 1. 1, 2, 3, comma, negative 1. And then what's A, since these are the endpoints of the major axis? What's the answer? Someone's whispering it. Apparently the rest of the class can't count. All right, so this is what we do. We have to fill this in. And I always do X first, then Y second, equals 1. And I have 4 parts to fill in. Guess what? I got 2 of them. Actually, I have 3 of them. X plus or minus? Minus what? And then Y what? Plus 1. There they are. And then where does the 5? Where does 5 go? Actually, nowhere. But according to what 5 is, what number goes under who? Huh? Who does what number? 25. There they are. We got some life. Okay, and then, oh, how ridiculous. Whose minor axis length is 8. How simple can this be? What number goes underneath here? 16. Minor axis length of 8 means I go up 4 and down 4 to get the other part. And then if I connected those dots, 1, 2, 3, 4, then that would be our ellipse. But my scale's all screwed up, so that's why it looks a little distorted. All you had to do is come up with the equation, so that's it. Mickey Mouse stuff. Oh, it's going to get more challenging. I don't know why I have this one. It's because when you're given a foci, it just requires a little bit more thought. 2 comma negative 7. 2, 3, 4, 5, 6, 7. 2 comma 1, 2, 3, 4, 5. All right. So where's the center? In the middle. 2 comma negative 1. 1, 2, 3, 4, 5, 6. Okay, so the center is 2 comma negative 1. So again, I just fill this standard form out as is every time, and we'll figure out what... By the way, who's going to get the bigger number? Underneath y or underneath x? Underneath y. Because... What's BI66? The foci go up and down, so does the major axis. Those are the rules. Okay, and then major axis length of 16. Major axis, this is going to go under, what goes underneath the y? 8 squared. 8 up, 8 down. That's what that means. Oh, and by the way, you already know this. So you're already 3/4 of the way there off of this simple information. What is 6? What letter does that represent? What's 6 represent? I heard someone on their last gasp of life say 30. It's C, right? Okay, so C squared equals, do we have A squared? Yes or no? 64 minus B squared. Subtract 64, but that's what negative B squared equals. So B squared, do I even have to root or no? No. Of course, the x-axis radius is the square root of 28. If you got it as a decimal, of course, simplify. So why do I have this grid here? I do the grid just to kind of make sure I know what I'm doing. All right, get a picture of knowing it's up, down, and getting my spaces counted correctly, so on and so forth. It's going to be great. By the way, eccentricity, think about it. All right, what if the radii were equal underneath x squared and y squared? What if the radii were equal? What do you actually have a picture of? Circle. So what would a squared minus b squared be? 0. And then that would be your c value. What's 0 over anything? 0. You would have an a value, whatever the radii value is. So the idea of eccentricity, it's a nice little number to demonstrate the shape of the ellipse. So just by that one example of when you get a circle, a squared minus b squared equals 0, so c equals 0. The closer c over a is to 0, the more circular the ellipse is. And of course, c is always going to be smaller than a. So c over a will never get to 1 in a true elliptical scenario. But the closer it is to 1, the more elliptical, the more stretched out it appears. So that should be something you understand as well. So we'll do that after we find this. What are we going to do with this? What did we do last year? Did we do this last year? Did we? I think we did. Didn't we complete the square? Yeah. So go ahead. Let's see what you do offline. I'm going to freeze the screen in class, but then I'm going to talk to the computer like a weirdo. So the first thing I do is this, and then I do this compared to those two things that I did that with. And then, of course, whatever I do to one side, then I take these two, but then I do this to these two. Does this help you go with your work in class? Yes, Mr. Fabulous. Add 23 to... Oh, shoot. I gave him a clue. Whatever you do to one side, of course you do to the other. So hopefully you recall that from last year. And then... that number. Of course, whatever you do to one side, you do to the other. Wrong! Because you actually did this to the other side. Some people done already? Are ya? This one actually is not hard. Last time I checked, that's what that equals. And actually it's like a 2-3 stepper, depending on how. Then of course we got to find our stuff. Okay, and then we'll find the stuff. So, completing a square, we get this. So, what did it say? I'd still like to get the center, even though it didn't ask for it. Everything's based off of the center. And then, what are the vertices? I don't care if it said that or not. What are the vertices? Does this go up, down, or right, left as far as the big number? Up, down. So, it's 1 comma, add 3. 1 comma, subtract 3. So, you shouldn't have to graph it to see that. You have to go 3 up and 3 down from the center. Then the foci, well, I should have done that real quick. I don't want to leak into the other question, though. C squared equals A squared minus B squared root 5. So the foci are in exact form. -1 plus or minus root 5. All right, did it ask for anything else? Oh, eccentricity. So eccentricity is E. Oh, I had blanks for this already. E equals root 5 over 3. Then I think we analyzed that. That's like 2 point something over 3 was like 0.7-ish. So more on the elliptical side than circular side. I don't know what else to say about that. Okay? All right. And then the next one, I don't know. I guess go ahead and do it. If you got the first one wrong, hopefully you get the next one right. So I'll do the same thing cryptically on the video. Freeze the screen. Freeze the video for a sec. 2 people got it right this hour. Uh-oh. All right, so is it frozen? Good. So first thing you do is this. You take this out. And I need to... You put a blank there. And then compare these. Do that. It's often screwed up is whatever you do to one side, say it. A lot of people forget that they're all proud of themselves on the left side. They mess up the right side. All right here. Okay, next step is the whole idea of doing this. You guys already done with this one? Shh. Then when you divide, okay, bigger axis here. So this is the center. But we're going to move that way and that way. The x-axis radius. Shh! Said that too loud. And focus is... And then the focus should be... By the way, I don't know what's going on. We're back to getting crazy in here. Eccentricity should be simplified in its simplest form. always, always, always simplify. Done. By the way, this is a contest. Go! Put it in standard form! That's what I want. I want this in standard form. Do it. Okay, how do I... What? Wait, this is... What is this thing? Okay, first thing you do is... And actually, quite proud of second hour. They knew what to do in order to compare it to what we just did last chapter. Quite fine. But then it was just a couple mathematical hiccups. Being quiet, but all this writing. Oh, by the way, people can't stand my voice anyway, so it's good for you online. Being quiet because everything I'm writing here should be known from what we did last chapter. So, shouldn't have to reteach some things. Freedom! Good foilers are good whats? Okay, and then, alright, what do I do at this point? Well, actually, we're almost right there. This is going to get a little bit crazy. By the way, it's an individual contest. What do you get? A prize from the prize box. I hate your prizes, Mr. Russ. Okay, so what I have to do next is subtract y squared. And then subtract 8y so I could go through the process of completing the square. Okay, so what I have to do with this is, and then we're going to have to bring this up to the top here, but when I take this out, this becomes this. Whatever I do to one side, do to the other. Oh, by the way, this morning I made this mistake. Made the mistake that, fine, this isn't a big deal, couldn't care less about fractions. There should not be one decimal written on your paper. If there isn't a completing the square format, I will mark you wrong so quick your head will be what? Okay, but this is the mistake I made. I shoved that over here. That's wrong. Then I was like, why am I not, getting the right answer? And then later on, when I redid it, I remembered that you actually added this to this side. So that's what you have to add to the other side. Okay, so now I'm going to drag this up here. I think I'm okay with about this much more space. Okay, so just put it in standard form, class. Now, you expect me to factor this? I hate you. It's actually right here. Okay, raise your hand if you say you got it. Come on up here because I know what the answer is supposed to look like. By the way, stop! Your answer has to be... Oh, this infuriated someone second hour, and he just wouldn't get over it. But or she, he or she, whatever person it was, it's random. It has to be x squared over a x squared, x minus h or k, or x minus h squared over a number plus y minus or plus a number squared over a number equals 1. Can be nothing upstairs with the x squareds and the y squareds. That's just the rules. If you don't like it, well then lump it. Hopefully I did that mathematically correct in my head. All right. Yeah, okay, so then I divide by this. The final answer is x squared over a number. Okay, hold on. No, what do you got? Where's it at? You didn't reduce. Always, always, always reduce. Sit down, and then come back. You're eliminated. You're just like that guy the last hour. Nope. You can stop complaining and come back after reduce, or else you're going to lose. It's the rules. That's the way it works. Sometimes that's life. No. That's life.